Okay, so this is the Intro to Java class 1.8, and we'll be talking about arrays. So let's say you wanted to make a bunch of variables, say 20 integers. It would be really time consuming to create 20 different integer variables. So what you can do instead is create an array, which is a type of collection that lets you organize your values in a way that's easier to access. So in Java, arrays are a type of collection or a list. You can store multiple values of a data type, like an array of integers or an array of doubles. And what you're doing is you're putting multiple values in one variable, and that variable is just an array or a list variable. Now, each item in an array is called an element. And just like a string, each spot, or the way you refer to a spot, is by the word index. So if I wanted to say the second index at an array, the second index of an array is equal to 1. Or if I were asking the element at the first index, then I would say it's 5. The element is 5. And remember that Java starts counting from 0. So the fourth element in an array is actually at index 3, and the first element is actually at index 0, just like a string. So there are two important things you need to know when you're creating a simple one-dimensional array. You need the type of the data that you're storing, like double or string, and you need to know the amount of elements you'll have in that array. So say we wanted to store a list of our top 5 favorite numbers, assuming that the numbers are integers. The type of data would be int, and the size would be 5. So this is how we would create the array. We first write the data type, which is int, and then we have 2 square brackets, which tells Java that we're creating an array of ints. Then we have the name of our array, which is just like any other variable. You put the name, and it could be whatever you want, and it's convention to put it in camel case. And then after that we have our equal sign, and we put new int, and then in square brackets we put a number, which is the size or the number of elements in our array. Don't worry about what the word new means for now, just know that you need to use this when you're first creating an array. And as always, we finish with a semicolon. So now that we created an array with 5 elements, we need to fill in these values. So by default, each of these elements is equal to 0. So if we wanted to add our 5 favorite numbers to the array, we wouldn't actually be adding anything. We would just be modifying the current values of that array. So just to reiterate, this is the code for the array that we created. And this is a visualization of what the array looks like right now. It's a list of 5 values, all equal to 0, and their index goes from 0 to 4. Now we have 2 lines here, and this code changes 2 of the elements in the array. So first it sets the value of the first element, which is at index 0, to 9, and then it sets the value of the last element, which is at index 4, to equal 2. And people often get confused and think that since the array has 5 elements, the last element would be at spot 5, but don't forget that Java starts counting from 0. And this is a visualization of what the array would look like after this code runs. We didn't change the values of the middle 3 elements at all, so they will remain as 0, but the first and the last element have been modified. So what if we wanted to put all 5 of our numbers in our array? If we were to add elements just like we did, then that would be 5 lines. And it's a bit annoying to write 5 lines, but it's okay. But let's say we wanted to make a list of our top 20 favorite numbers. Then we have to keep writing this almost identical line over and over again, and it just becomes unreasonable. In programming, you want your code to be scalable, which means that if we're given new requirements or a bigger size of something, like wanting to do top 20 numbers instead of top 5, then we want to be able to easily adapt our code without having to write too much. Because let's say for some reason we wanted to put our top 200 numbers. We definitely do not want to write 200 lines which are all basically the same thing. So one way we could fix this issue is to add all of the elements in the beginning when we create the array. And we can do that like this. So after our equal sign, instead of having what we had before, we can use curly braces and just put all the values inside, separated by commas. And Java can automatically detect the size based on the number of elements you put. So Java knows that this array has 5 elements, so the size is 5. And for comparison, here is the way we created the array without giving it any specific values. So it's not too different, and it's not much longer size-wise to just initialize the values in the beginning. But what if we wanted to have an array with the numbers from 1 to 50? We just learned that we can give an array values when we create it, but then we would have to type out every single number from 1 to 50 in between those curly braces, which can be annoying, especially when, once again, what if we wanted to change that from 1 to 500? And what if we wanted to go to 10,000? So we need our code to be scalable, and that means that we can easily change a few characters or a few numbers, and then we can go from 1 to 500 instead of 1 to 50. So this is what it would look like if we were to write out each line, and obviously if you were going from 1 to 500, it would be 500 lines. But notice how we are basically repeating the same line with a slight modification in the number. And what did we learn we could use to easily repeat the same or similar code? Well, we can use a loop. So first we create our array specifying the size 50. And then we have a for loop which goes from 0 to 50, not including 50. In our loop, we use the array and we get the index based on I. So when our loop first runs, I is equal to 0, and we can access the first index. In the final iteration of the loop, I will be equal to 49, and we'll be getting the index 49, which is the final index of the array. Notice how our loop never goes to 50, because once this condition is no longer true, meaning let's say after 49, I is increased by 1, and now I is equal to 50. Is 50 less than 50? No, that it's not. So this loop will stop and it'll continue with the rest of the code, which is what we want. Because let's say we put here numbers and then 50. We were accessing the 50th element. There is no 50th, there is no index 50 in our array. So our program would actually throw an error. Anyways, we set the value at whatever position I is at, and we set it equal to I plus 1. So think about why we do this. Well, the reason is that the first index is at 0, but we want our values to go from 1 to 50. So we just set the value to be index, or I, plus 1. Here's a visual representation of the array, and you don't have to look at it much. As you can see, it goes from 1 to 50, and the index goes from 0 all the way to 49. And make sure you understand why we're starting from 0 and putting I plus 1 here. Because let's say we just said numbers at index I equals I. Then we would be going, in our first iteration, for example, we would be doing 0, numbers at index 0 equals 0. And automatically that's not what we want, because we just want to go from 1 to 50. Now we know how to create and add to an array, or, well, modify an array. So how would we actually use the array's values? So for example, if we wanted to print the third number. Here we have a double array with 4 elements. A double array acts the same as an int array, as we've already seen, but now it just stores double types instead of ints. Now, say we wanted the third element in the array and we wanted to store it in a regular double variable. This is how we would do it. So we create our double variable using the double keyword, and we have the name of our variable, which is chosen number. We put the equal sign, and we access the index 2 value for numbers. So we put the name of the array and then the element at index 2. So what do you think this would be? Well, this is at index 0 and 5.2 is at index 1, so numbers at index 2 would be 10.9. So this is essentially saying double chosen number equals 10.9. And if we wanted to directly print the third element without any variable, all we'd need to do is this. So we have our normal print statement, and we don't need to use the variable at all actually. We can just put the value directly in here. So numbers at index 2, and this would just print out 10.9, just like that. So now what if we wanted to display all the elements in an array? So think about what we'd be doing. We need to go to each element and print out its value. And remember that we don't want to repeat code by going to each element and writing multiple lines to just do the same thing. So we can replace that by using a loop. And here we have our 5-element integer array, and we have the for loop, but you'll notice something different. The condition for the loop, meaning what the condition that it needs to be to continue, is when I is less than numbers.length. So numbers.length, as you can see, the variable is named numbers. This is a way of getting the size of our array. So let's say you didn't know that this was 5 elements long. I mean, it's short, so obviously we can tell there's 5 elements here. But let's say it was 50 and you didn't know how many there were. You can use numbers.length, and this will just replace this value with the size of the array. So this is basically saying I is less than 5 right here in this case. But notice that we put this, and if we had put I is less than 5, then that wouldn't be good, because once again our code needs to adapt to changes. So if this was just I is less than 5 and we decided we wanted to add another number here, just add in another, maybe 3, 5, 10, 29, 8. Then our array size is now 6, but the number here would still be 5. And our loop would not go through our entire array, and it would not serve the purpose that we want it to. So it's important to write it like this, because let's say you had 20 loops later in your program and they all wanted to go through every single element of your array. Then you would need to change the value if you just wanted to add one thing here. You added one value here, you'd need to change this from 5 to 6. So it's good to use numbers.length, because this will automatically adapt to whatever changes you make here. So if you add 8 here, then this will automatically adjust the I is less than 6. Alright, so in our loop we have our print statement, and we put numbers, and once again we access the element at index I, and then we put a space. So this is what the output would look like. And as you can see, it printed all the values, but it also put the space because we told it to. And so really there would be a space after this 9 as well, because it would do, on the final iteration, it would do 9 plus space. And when you're listing values like this, it's good to put like a space or maybe a comma or something like that, because if we had only printed numbers at index I, then it would just be 3, 5, 10. It would be hard to tell what it is. Maybe they would be close together, so you might think it's 35, 10, 209, for example. So some notes about array indices is, first of all, you can't have a negative array index, so you can't try to access an element at index -5, because that just doesn't exist. And yeah, the first index is 0, we've covered that, and every index after that is increasing by 1, so it's always going from 0 to whatever. And the next thing is that array indices must be integers. For example, there's no 3.5th element in an array. And all of this should be intuitive. For example, if you just had a list of names, you couldn't really say like the 3.5th person, right? It would be the 3rd person or the 4th person, but there's nothing in between. So all of this is just like a real life list. And lastly, your array indices must all be smaller than the size of your array. So for example, if you had an array with 5 elements, you can't try to access index 5 or index 20 because they just don't exist. Index 4 is the last index in an array with size 5. And if you were to make it in an array of size 6, then your last index would be index 5. So because we're going to be using it in a little bit, we're going to review how to generate a random number. So math.random generates a random double in the range from 0.0 to 1.0, not including the 1.0. So these are some examples of what it could generate. An actual math.random would produce a longer value, but I just shortened it here. So you might have like 0.50840010, 109, and just so on, until the maximum decimals for a double is reached. So if math.random only generates from 0 to 1, we need a way to generate from 0 to any other integer that we want. For example, 10. And we can do this by multiplying the result of math.random by that number, so by 10. And now the range of possibilities is multiplied by 10. So it can generate anything from, instead of 0.0 to 1.0, it could be 0.0 to 10.0. And this makes sense, right? Because let's say the normal math.random value generates 0.5 and then so on. If you multiply this value by 10, you would get 5.0 and so on. So now you have 5 point whatever. And if you cast that as an integer, or you convert that to an integer, you have 5 instead of something in between 0 and 1. Now you have something between 0 and 10. And you know it's going to be between 0 and 10 because let's say this is the maximum possible value, 0.999999. And then you multiply that by 10. You get 9.99999. And then when you cast it as an integer, it truncates, meaning it cuts off the decimal, so it'll just be 9. So actually, this would generate from 0 to 9, sorry, not 0 to 10. But if you wanted to generate from 0 to 10, then I guess you could round it. Or you could just convert this to times 11. So, yes, now the range of possibilities is 0 to 10, and yeah. So what if we wanted to randomly select an element from an array? So you had a list of numbers and you just wanted to pick a random one out of there. Well, first we have to think about how do we pick an element from an array in the first place. We use an integer index to access that element. So really all we need to do is generate a random integer that would serve as our index. And that integer has to be in the range from 0 until the end of the array. And the end of the array would be the size of the array. So we can generate using math.random, and then we multiply the result by the length of the array. But the problem is that this would give us a double value, because math.random is double, and so if you have 0.59 here, and you do times numbers.length, which we'll just say it's 10, then you'll get 5.9, which is a double, and you can't use a double as an index. So now what we need to do is cast this whole value as an integer. And we can do that by putting int in parentheses and then casting this entire value. But one thing to notice here is that we put parentheses around this entire thing, math.random and numbers.length. And we didn't have that here. So think about why we did that. Well, the reason is because if we did not have these parentheses, then it would go in order. It would cast math.random to an integer, and then it would multiply by numbers.length. Right now, when we put the parentheses, it is first looking at what's inside of here and evaluating this. So first it's doing math.random times numbers.length. But if we didn't have this, it would be math.random, convert it to an integer, and then times numbers.length. And so think about why we don't want that. So think, let's say math.random was equal to 0.4. If we cast that straight to an integer, it would just go to 0. And then regardless of whatever numbers.length is, our random index would end up being 0. And this would always happen, and you would just end up with 0. So by putting these parentheses, you're first doing math.random, now you get 0.4, and then if you multiply it by 10, now you have 4 whatever, and now you can cast it to an int. And so now you have 4 as your random index. So that is all, and now we have 3 practice problems. Actually, I think we have 5 this time for you to try out. And yeah, so these are exercises 1 and 2, and 3 and 4, and finally this is a bit of a challenge, but this is exercise 5. So as always, if you have any questions, you can email us or join our Discord server, and we'll be happy to help and answer any questions. That's all for today, guys.